Morning. Today we're going to look at section 11.6. We're going to be looking at simplifying radicals. Now if you can remember in chapter 9 we did some simplifying of radicals already, so this is going to be very similar to that. They're just going to look like a little more complicated underneath the radical sign, and sometimes they might be fractions underneath the radical sign. But what I want you to try to dig out maybe is your half sheet with your perfect squares on it. And if you can't find that, you could probably print it again out of the Google Classroom materials, or I'll write the first few perfect squares on here again for you so you have them. Remember, I'm going to be asking you, what does each of these numbers come from? So for instance, 100 comes from 10 times 10, 49 comes from 7 times 7, and so on. Okay, so the key rule that you need to remember about everything with radicals is that you have to reduce. Anything under a radical sign must be reduced as far down as you can. So in other words, don't leave any perfect squares underneath the radical sign. Okay, we're going to start with a few easy ones. Number 1, square root of 25. That should be right on your list. Everybody should know that one right away again. 25 comes from 5. Underneath the next one, 40 plus 9. Go ahead and do the addition. Square root of 49. That one's right on your list. 7. 18. 18 is not a perfect square. You have to break it apart. So now we're trying to remember what we did in chapter 9. What's the biggest perfect square that multiplies together to give you 18? Now remember, it doesn't do any good to pick 6 times 3. 6 and 3 are not perfect squares. 9 times 2. 9's on your list. 3 root 2. 24. Biggest thing you could think of that is a perfect square that goes into 24. 4 and 6. Square root of 4 is doable. 6 is not. Drop down the square 6. Now we're going to get into variables. Every even power is a perfect square. Remember that rule. Every even power is a perfect square. The way you reduce perfect squares when they're variables is to take half. So the rule inside a perfect square is a 2. Remember, it's like you could take this number 2 and put it underneath here, and you're doing a divide by. 4 divided by 2 is 2. X to the 2. So you're cutting it in half. Every even power is a perfect square. Cut that number in half. So square root of x to the 4th becomes x squared. Now the next one. Square root of x to the 3rd, y to the 4th. You could do the y term right away. Cut the y in half, and you get y squared. So you know you're going to have that. But x to the 3rd, that's not an even power. That's an odd power. So you're going to have to break apart x to the 3rd. Now the way we break these apart, always do this way. Take the one number less than what you started from. X to the 3rd. One number less than 3 is 2. X to the 2 times x to the 1. Put your square root signs on both of these. Now you have part of that is a perfect square. So x to the 2nd, square root of x to the 2nd, you can do that one. Cut it in half. 2 divided by 2 is x to the 1st. So this part becomes x to the 1st. Square root of x to the 1st does not reduce. That odd power is as low as it could get, which is not reducible. So your answer for this one is x to the 1st times y squared times square root of x. We're going to practice a lot of these odd powers here in just a little bit. All right, the next one. It looks complicated, but it's not. You've got a parenthesis. X plus 4 raised to the 2nd power. This is an even power. That means it's doable. 2 cut in half is 1. So they cancel. You're left with the quantity of whatever it started with, and then half of 2 is 1. Done. X plus 4 to the 1st. Number 8, same way. Square root of 3 minus x to the 10th power. 10 is an even power. Cut 10 in half. Yep, 5. 3 minus x to the 5th. Done. Make sure you take the square root sign off. All right, these next two, we're going to have to break these apart. 75. We'll do this in two pieces. What's the biggest thing you can think of that goes into 75? That's a perfect square. I hope you came up with 25 times 3. X to the 5th, that's an odd power. So just like we did on that last one for the first try, take 1 less than 5. 4. Everybody agrees that 4 times 1 gives you 5. That's how we're going to break this apart. Now we've got some perfect squares here. Square root of 25 is doable. That's 5. I'm going to hop over this square root of 3 for the second, and I'm going to look at this one. Square root of x to the 4th, that's an even power. That's not doable. Cut it in half, x squared. So those are the two doable pieces. The other two that are sitting here are not reducible any longer. So put them together under one radical sign, 3x, and then it's finished. 5x squared times the square root of 3x. All right, number 10, x to the 11th, odd or even? Good, odd power. Can't do odd powers. Break it apart. What's 1 less than 11? 10. X to the 10 times x to the 1. Now you can do the first half. 10, even power, cut it in half. 5. Take off this radical sign. It's just x to the 5th, and then the part in the back is just going to drop down. Square root of x. X to the 5th times the square root of x is your answer. Okay, put your video on hold, put it on pause, work the first part, page 832, 2 through 6, 24, 25, 27, and 28. When you're ready, go ahead and turn your video back on. Okay, now we're going to look at some that are fractions. It totally depends on what they look like. For some of the fractions, you might be able to write them as 2 little baby radicals. If you can write them as 2 little baby radicals, maybe something will reduce. Some of them, you might want to try to reduce the fraction first. If you can reduce it first, you might get something that is then a perfect square. So it all depends on how it looks when you begin. All right, so number 1. Square root of 5 over 9. 5 over 9 does not reduce. So for this one, I'm going to try to break it up into 2 radicals. So instead of 1 giant radical sign, we're going to make 2 baby radical signs. So each number has its own radical. The square root of 5 does not reduce, so we can leave it. But 9 is on our list. That's a perfect square. 9 comes from 3. And this one is not done. We only could reduce part of it, but that's okay. As long as you reduced whatever was a perfect square, this one is finished. Number 2, square root of 1 over 4. Again, for this one, we're going to break it up into its own 2 little baby radicals. The square root of 1 is 1, and the square root of 4 comes from 2. The answer is 1/2. 81 and 16. Hopefully everybody recognizes those numbers right away. Write them separate. Square root of 81 over square root of 16. Each one of those is on your list. What does 81 come from? What does 16 come from? There you go. 9 over 4. Number 4. Square root of p to the 6th over q to the 10th. These are letters, but that's okay. You can break apart instead of 1 great big radical. You can write this as 2 little baby guys. Square root of p to the 6th over square root of q to the 10. Each one of those is an even number. That means they're both doable. What's half of 6? 3. And what's half of 10? Q to the 5th. Done. Now, number 5. This one can actually reduce. Can you think of the number that goes into both 12 and 27? Biggest thing you could think of that goes into both 12 and 27. Yeah, it should only be 3, so let's reduce them both by 3. 3 goes into 12 4 times, and 3 goes into 27 9 times. So now what we have is the square root of 4 over 9. Now I'll go ahead and write it as pieces. Square root of 4, square root of 9, and those are both on your list. What does 4 come from? And what does 9 come from? There you go. 2 over 3, 2/3. One more page. Number 5, square root of m to the third over 9m. On the bottom, m. Everybody agree that this is m to the first? Now we can use our quotient property, m to the third over m to the first. Bigger on the top, keep it on the top, subtract. What's 3 minus 1? M to the second over 9. Now you can do your two baby fractions. Square root of m to the second over square root of 9. Each one of those is doable. M to the second, even power. Cut it in half. M square root of 9 comes from 3. Number 6, 4x to the fifth over 25. There's 3 pieces here. 2 of those pieces are perfect squares. X to the fifth, though, we have to break that one apart. Okay, so let's do pieces. Square root of 4, square root of. Now remember, when you have an odd number, break it apart 1 less than, so x to the fourth plus that leftover x to the first. And on the bottom, we've got square root of 25. Okay, you have all kinds of doable pieces in here. Square root of 4. 4 comes from 2. Square root of x to the fourth. 4 is an even power, cut it in half. X squared. Square root of x to the first. Remember, when we get down as far as x to the first, you can't reduce that, so just drop it in. Square root of x to the first. And then over, and then 25 comes from 5. Number 7. Square root of 40z to the fifth over y to the second. All right, we'll have to do a little breaking apart again. 40 is not a perfect square on our list. So the biggest thing we could think of that goes into 40 would be 4. 4, 10. Z to the fifth, again, that's an odd power. We can't keep odd power, so just like the last one with x to the fifth, we're going to break that apart. Square root of z to the fourth, 1 less than 5 is 4, z to the fourth plus the times z to the first over. And then we can leave this one alone, y squared, because that's already an even number. All right, let's go through everything that we know how to do. Square root of 4, that's on our list, 2. Z to the fourth, I'm going to jump over here to the z to the fourth, that's an even power, cut it in half. Z squared. I can't do the 10, and I cannot do z to the first, so I'm going to put those together in the back. 10z to the first, put those together in the back, over, and then square root of y squared. That's an even number, cut it in half, y to the first. There you go. That was a lot in that one, number 7. And number 8. This is the last one. Try to slide this out of the way if I can. There we go. All right, square root of 64x to the third over 16x to the fifth. 64 and 16, those are on our list, so those will be the easy ones. Let's do the letters first. X to the third over x to the fifth. We can reduce that. Bigger on the bottom, keep the x on the bottom. We need to subtract from the bottom up. 5 minus 3 is 2. X to the 2. So we have 64 over 16x to the 2. And let's write that as separate little pieces. Square root of 64, that's the top. On the bottom, square root of 16, square root of x squared. Every one of those is a perfect square. What does 64 come from? 8. What does 16 come from? 4. Square root of x to the second, cut it in half, x to the first. And now we can do one more thing. 8 over 4 reduces. How many times does 4 go into 8? Yeah, 4 goes into 4 once, 4 goes into 8 twice. Be careful how you write this. The answer is not 2x. The answer is 2 over. You've got an x on the bottom. 2 over x for that one. Okay, so there are some samples for you of simplifying your radicals, fractions and regular numbers. You're going to continue with the same assignment, page 832. Try numbers 8 through 13. All right, we'll see you next time.